Good morning, good afternoon, everyone. Welcome to today's Explorer Classroom Hangout. My name is Joe Grabowski from National Geographic, and I will be your host for today. For those who are just tuning in for the first time this month, we are taking a deep dive into the issue of ocean plastics. So some of you might know, but we are putting about 8 million tons of plastic into our ocean each year. That's the equivalent of about a dump truck every minute. So it's a serious problem. It's a global problem, and we need to come up to some solutions for it. So all month long, we've been connecting with scientists, explorers, artists who have been dedicating their time to researching the issue, to sharing and spreading the word about it, and of course, looking for solutions that we can use in our homes, we can use in our businesses and our classrooms. So I want to give a quick shout out to any classroom who's starting to tune in live on YouTube with us. Don't forget, you can still get in on the action. Introduce yourself in the chat sidebar on the right. Let us know where you're watching from and send us in some questions. And of course, to any classroom, whether you happen to be on YouTube or tuning in live right now, make sure that you take some pictures, share them on Twitter, hashtag Explorer Classroom, tag at Nat Geo Education. We love to see pictures of classrooms in action. So I can see we have a couple more classrooms who are just jumping in with us right now, which is awesome. And we're going to get to our guest of honor. So really excited to have Justine Ammedolia joining us today. She is a marine biologist, plastic pollution researcher, and a science communicator. She's coming to us from St. John's, Newfoundland today in Canada. In 2014, she had a National Geographic Young Explorer grant, which allowed her to travel to East Greenland to research Arctic seabirds and live off the grid in a hunting cabin for 6 weeks. Pretty awesome. So during this time, she fostered a passion for the northern areas of our planet and became more and more aware of the issue of ocean plastics. So since then, she's been able to travel to places in Arctic Canada as well as Western Greenland to sample plastics from our waters. And she also works as a garbage detective. So she researches the plastic landscape on the coastlines around Newfoundland. She works with local fishermen and such to find out how these are moving around and how it's impacting Newfoundland waters. So Justine, it is so great to have you joining us live today. We're excited to learn a little bit more about what you're up to. And then of course, we'll let the students fire away with some Q&A action.
Awesome, right on. Hey everyone, so thank you so much for joining me today. I'm really excited to be calling you from our local museum in Newfoundland, the Johnson Geo Center. And I'm actually calling with a background of a whole bunch of different types of plastics that we use in our everyday life. So I'm really excited to be calling from an awesome exhibit. So I'm going to start off by giving a presentation, a bit about myself, and then I'm going to be really happy to answer any questions. So I'm just going to share our screen here and get this PowerPoint on the go. Should be over here, share screen. And then, can you see the screen, Joe? Joe?
Yeah, looks good. Just have to take it full screen for us.
Perfect, right on. All
Perfect.
Right. So starting off, my name is Justine Ammedolia, and as you can tell from my accent, I am Canadian, so I'm a bit further up north from some of you folks. And I'm going to talk to you about how I got into becoming a garbage detective. I'm really, as a scientist, really fascinated by plastic pollution and garbage and how it ends up in our natural environment. And since I grew up in Canada's largest city, in a place called Toronto, I didn't really have too much exposure to the ocean, which is a bit strange for most marine biologists because people usually study what's in their backyard. And for me, I was always fascinated by all the different types of marine animals like whales, sharks, fish. And really my inspiration to get into marine biology, being a kid from the big city, was really from going out to family vacations in Florida. So my parents would bring us all the way down to the southern US, and every summer I had the opportunity to go explore this beautiful ocean. And this really inspired my love for the ocean and for wanting to learn more about the different fish that we share our planet with. So as you can tell from this picture, my head's right in the corner, and it was really hard for my parents to drag me out of the water because I was always just so eager to study everything that was underneath. Now, I basically went to the University of Guelph. So after high school, I went to go study marine biology full time. And it gave me this amazing opportunity to go out and really get a good understanding about all the different corals and fish down in the tropical oceans. But after studying these animals, I realized I really wanted to go back to Canada and kind of keep to learn more about the oceans that we have up by our backyard. So I ended up going to college where I studied biology, and I met this amazing professor and really good friend now, Dr. Shoshana Jacobs. And what's special about Shoshana, who's kind of like your teachers that in your classroom now, was they really inspired me to want to learn more about Arctic environments and places that were really cold and hard to get to. So after listening to Shoshana's lecture, I asked if I could go up to the Arctic myself, and it was really surprising because Shoshana said, yes, just come up with this big project idea and we'll talk through it and we'll try to find money for it. So I ended up doing that. And what was really crazy was I got money to go and do a science project. In fact, I wanted to go study in a place called Greenland, which is it's a country that's very far away from the US and Canada. And it's the biggest island in the world, and it is absolutely beautiful. You can see all that little white part in the middle is all ice because a lot of glaciers are there. So I ended up getting this project funded. So I went all the way up to Greenland to study seabirds for that summer, which are just birds that hang out in the ocean a lot. So I went all the way up specifically to a place called Cap Ho, which doesn't have anybody living there full time. There's only a cabin and some people will go hunting, but it's not like anybody lives there full time. In fact, it's home to about 2 million seabirds that live there the entire summer. And what these birds do is they go and they basically, they mate. So you have a mom bird and a dad bird, and then they have a chick. And they basically, their whole job that summer is taking care of their chick and making sure that it survives and it gets nice and fat so it can fly off to the ocean. So getting there for me was quite an adventure because, like I said, nobody lived there. So I was actually in charge of getting my own helicopter. So I went from sitting in a classroom like you folks, all the way to booking my own helicopter ride, which was just really crazy. And you can see I'm right in the middle there. And that's actually the backdrop with all the mountains. That's the place called Cap Ho where we studied. Now you can see this is the field. So this is my office where I lived for about 6 weeks. Is all the way at the bottom. That little red dot there is where we lived. You can imagine it's quite an adventure going out there. Like I said, there was one cabin and it only had one room. So I was living with 4 other people in this tiny room. And that's where we cooked, we lived, we hung out after all of our science surveys. And we were basically eating crackers and sardines, a lot of canned food, because you can imagine going all the way up to Greenland, it's really hard to ship up your food up there so that you have fresh stuff. It was mostly cans. And to get water, we were melting icebergs to drink. So that was really cool because there was like no running water streams around us. But maybe my favorite part, which I think you guys would find funny, is the toilets. We were basically using this toilet in this washroom, which was surrounded by mountains. And it was just an absolutely crazy experience because it was such a beautiful view. Now, with the science that I was doing up there, I was studying these birds called little auks, and they look like cans of Coke. They're about this big, so super tiny, and they look like miniature penguins. And they are incredible birds because even though they're really small, they can fly almost 100 miles away from their nest to go get food and bring it back to their chick. So they're really hardworking birds. I was really curious was where the birds were getting their food from when they were going out to the ocean. I wanted to know where they were getting their food from to feed their chicks with. So I decided to put these little backpacks on the birds to see where they were flying off. But the catch was that I had to remove the little trackers, the little backpacks, when the birds came back, so I could download all of that data. Now, what happened next, I didn't expect, is that all the birds actually ended up losing their backpacks in the ocean. And I was terrified because it's almost like when you fail a test and there's no chance to repeat it. With me, I had no project and I was so scared that I failed this entire expedition. But what ended up happening was that I kind of I think I was in the middle of crying at that point in the mountains. And I realized that I made it all the way to this beautiful, beautiful place that you see in the picture. And even though I failed, it didn't mean that I couldn't save my project and think of something new and come up with a solution. So that's exactly what I did. I ended up thinking instead of studying where the birds were getting food from, I wanted to study what they were eating instead. So I thought the only way I could do this without any help or any equipment was in fact to collect bird poop. You heard that right. I collected bird poop. There's 110 samples. Those little tubes in the corner are individual samples of poop. And I collected them by catching the birds one by one, holding them on a notebook, and basically waiting until they gave me my samples. So biology sometimes isn't the most glamorous, but there's many, many different ways that you can study animals that doesn't require a lot of equipment. So this whole experiment saved my project, and I left this beautiful place that was my office and feeling very inspired by the natural world. And I thought I was on the right track with studying biology. But for me, when I got home, I actually learned that the birds I was studying that summer, the moms and dads, were feeding their chicks plastic. And for me, this really, really made me sad, because I thought that if I was going to be a marine biologist and this person who problem solves and, gets my way out of these situations, I wanted to learn how to solve problems that were related to humans negatively impacting our environment. How can we make these birds home cleaner for them and make sure that we don't leave garbage in their backyard? So I ended up pursuing to study plastic pollution, so garbage in the ocean. Now, National Geographic did a magazine cover on plastic, and what it looks like, the shopping bag's made to look like an iceberg, which just goes to show how big this problem is. For over 50 years, or for over 70 years, we've been mass producing plastic. So it means we make a lot of it, right? Even in the exhibit behind me, you can see how many different types of items there are of plastic. And after we're done using these plastic items, we don't know how to dispose of them properly. Recycling doesn't cover all the plastics that we throw in the garbage. A lot of it ends up in our oceans and in landfills. So unfortunately, it's a really big problem. So I'm really intrigued with studying how to get out into the environment and understand what kind of plastics are occurring. I want to give them names and I want to understand where they're going. So you can see the microplastics behind me. That just means they're really tiny pieces of plastic. So if you look at any kind of garbage that you throw out, it doesn't stay that garbage forever. It actually breaks up into these really tiny pieces that you can barely identify. So my job right now is to basically be a bit of a garbage detective. I'm interested in going to these beaches and understanding what's the garbage there, whether it's big or small, and try to identify these patterns of where it's ending up and why. So like Joe mentioned, I live in a place called Newfoundland. It's a province in Canada that's the furthest east you can get. And what's beautiful about Newfoundland is you have the field sites, like where my office is, how you saw the mountains before. These are my offices now. And they're absolutely stunning during the summer. The water's blue, it looks very tropical. But then I also do work out in the winter, and you can see how quickly it changes. It's very drastic. There's a lot of ice, snow, winds, but that means your science doesn't stop, that you have to keep on going to understand how plastic ends up on these beaches. You can see from this picture here that me and my colleagues, Just Melvin and Madeline Burry, the ones I work with now, we work in people's backyards. You can see there's houses all around us. As we're doing our sciences, people can literally look outside their window and see what we're doing. And for me as a scientist, this is really exciting because I'm not in an isolated area anymore. I'm working in people's backyards. And this means that we can basically work with the people in these communities. And it's great because we do cleanups with people. If they want to come out and work on the science with us, they do. But they also give us a lot of help in understanding what kinds of garbage are ending up in their backyard because they know so much. So a couple fun examples of the garbage that we find include this piece, which is really weird. It's burnt and it's charred, and you can see that it used to be a bottle and it was really flat when we found it. And this happens when plastic changes over time. It doesn't always stay in its form, like I mentioned, and sometimes people burn garbage and plastic because they think it's easier to get rid of it. But unfortunately with plastic, it just takes on all these different forms. So you can have these burnt pieces. Another really interesting piece of garbage that we find, which it blew my mind when I saw it because I had no idea if they were real or fake, are plastic plants. So these little plants, I would walk by in fieldwork and think that they were natural and that they were growing in the middle of garbage. And I thought it was so exciting because we could have life amongst all this garbage and pollution. But actually these plants are plastic. And it's really sad to see that humans have created nature or plastic that looks so closely to nature that it fools us. Now, a lot of the garbage that we find tends to be fishing related, which makes sense because a lot of people fish in our area. And it's not just in Newfoundland, but it's really anywhere on the east coast of North America. And, you know, it's really not their fault when things get lost because there's a lot of wind and winters are really bad. So things get loose and they get lost. The buoy I found that I'm holding is big, and you can tell that what it generally was used for, right? It's a big floaty kind of ball. But actually, when you look closer, the buoy's not so much the problem. It's the ropes. You can see the rope here. It's all puffed up and it's frayed into all these little pieces. These ones are really concerning because, you know, this is where the garbage detective skill set comes in, because we were able to make the connection between these little plastic ropes and these little threads here. And to be able to go into the field, and that's what biology and science is all about, is being able to problem solve and, you know, make those connections and understand how plastic changes over time. So it's a big part of the job. Now, the way I do science with my team over in Newfoundland is really awesome, because what we try to do is we use tools that are accessible to anyone. It means that if somebody wants to do the science that we're doing, they can do it in their own backyard. It shouldn't be impossible for people to use the same kind of approach and methods. So we use this cell phone app called Marine Debris Tracker, and it is amazing. You can download it on your phone for free through yourselves or your parents. And anytime you go out for a walk in your community, you can basically log all the garbage you see. So it's like, if any of you play Pokemon, it's like catching Pokemon, but catching garbage, which the job never ends. And it's actually really fun because you can start competing with your friends and family. And with this, it gives you a great idea about the different types of garbage in your backyard. And that's what we're doing with our science, is we record all these different types of garbage, and we're creating one big map of how does plastic look like from beach to beach to beach. You can see here, it's pretty awesome with the design. You basically, if you find a garbage bag on the floor, you just click on it and you add it, and this gives you basically one big map of where you find all these different garbage bags. Now, there's also many other types of ways that I study plastic, and I won't get into them because I would love to hear questions from you guys. Another way that we do this is we go out and work with fishermen, and we collect fish guts, and we see what the fish were eating. So we collect their bellies, we take a look inside, and these are fish that are being caught for food, but we just check inside of them because usually the stomachs are thrown out. And it's a really, really great way for us to kind of get an idea about how plastics on our beaches end up in these really beautiful animals and different ecosystems. So you can see here that this was our lab setup, and this is actually my partner, Jackie Saturno, who does a lot of work with fish guts in Newfoundland. And I was her lab assistant for summer. So there's another way that you can study plastics. It's a really dynamic material, and it just ends up everywhere. So ending off with this, becoming a marine biologist is a tricky business. There's not exactly one career path. You can take so many. But in terms of where you get to see beautiful parts of the world, it's a really exciting opportunity to get out there and, you know, try to tackle these really big issues like plastic pollution. So I'm really excited for your questions, and thank you so much for listening to me, guys.
All right. Justine, thank you so much. That was awesome. Yeah, it's a beautiful part of the world you get to work in that you call your backyard. And it is too bad that you see so much of that on the beaches, so much of that plastic. And but it is good to mobilize the community and have them involved. And so in the work you've been doing so far, have you found that you know, people are pretty open to talk to you and share their stories and such?
Oh, for sure. And yeah, because I'm sure, as most of the classes know, plastic has been around since we were all born. It is just everywhere and anywhere. And it doesn't matter how old you are. It's like my parents are, and they're coming close to 60. And they all have stories about how they remember when plastic took over their lives. And, you know, it went from paper bags and all these different other materials into plastic. So it's really interesting because you don't have to be a scientist to really talk about it. And it's really useful working with communities because they have so much to say about it. And it's really not our fault that it's all ending up in the ocean. It's just the way everything's kind of put together.
All right. Well, I say it's time to meet some classrooms. A quick reminder to any classrooms tuning in on YouTube. Introduce yourself on YouTube. You can send in a couple of questions. We'll keep an eye out for those. But for now, let's get to our first live classroom. Let's start off with Mr. Bruno's group. They are in Georgia in the US. Looks like a grade 4 classroom. Let's get that microphone turned on. There it is. How are we doing, Georgia? All right, who's up with a question?
How much plastic can you pick up in one day?
Oh, that's a great question. It depends the type of day, but I think the most we've ever picked up between 3 people was about 4,000 pieces. And we're not even talking like big plastic, because if anything, big plastic would be super, super easy to pick up. It is all those small, tiny little bits. So we've picked up 4,000 really tiny plastics, which, you know, you literally sit down on a beach sometimes and you don't move for a full hour because all you're doing is just picking it up. So yeah, a lot of plastic.
And that really gives you an idea of the scope of the problem, is that in one small area you can find so many pieces, and it's not all from the same thing, is it? It's tons of plastic that's broken down in the sun to these little tiny microplastics and is now all over beaches all around the world.
Exactly.
Okay. Let's see. Mrs. Holland's group, they're hanging out with us in Arkansas. Looks like a grade 7 classroom. Let's get that mic turned on. How we doing, Arkansas? All right, who's up?
How long does it take you to like clean up?
How long does it take for, sorry?
To clean up.
To pick it up.
Yeah.
Oh, you can spend literally a lifetime picking up plastic. When we go out into one beach, for example, we'll spend 8 hours, about 8 hours when it's really, really tricky, right? But the problem is that, you know, when the ocean comes back with the waves and like the tide goes up again, more plastic just keeps on coming. So for one beach, it might take 8 hours to clean it up. But the problem is that there's so much more plastic in the water and on the bottom of the sea that every time the waves go back and forth, more plastic comes in. And that's what makes plastic really, really good for polluting, is because it has lots of places to hide. It can literally go to the bottom of the ocean and it can stay there for decades. It can stay there for tens of years. And, you know, if there's a really bad storm, the ocean will get mixed up a little and then you see it right back on the beach. So in our cases, which is really interesting, we've been finding plastic that's older than me, but like it still has the dates. I think in one case we found a fishing tag from the 1970s. And to think that plastic has been in the ocean for over 30 years is really crazy.
And then, so I think that's an awesome point, Justine. We've talked about this a few times with some of our other events, is, you know, it's like a bathtub. If your bathtub is overflowing, you're not going to spend all your time mopping around the bathtub. You're going to turn that tap off. And I think that's the key here, is we've got to stop the plastic from coming in the first place. Then those cleanups can be more effective.
Oh, for sure. And that's one thing where, you know, the cleanups are great, but how we're doing these cleanups isn't just to go and clean up the beach and make it clean for a few hours. It's really to go in and to be strategic about it. Because like what Joe said, if there's a whole bunch of water in your classroom, you want to look where the water is on the floor to identify where is it coming from. You want to map out these plastics and understand, okay, are there fish tags coming from somewhere else? Or are there these plastic bags from a certain store? Or are these candy wrappers from a certain place, kind of deal? So if you can kind of map out this garbage picture and understand all the different types of items, then what you can do, which, you know, is kind of sciencey, but also politics as well, is then you work with your local community and you advocate for banning certain types of plastic. So in Canada right now, which is really exciting, is the government announced that we're going to stop making certain types of plastic and we're going to stop selling them, like garbage bags or like grocery bags that people get at the stores. And this is one way that we can save a lot of time and just not cleaning it up.
All right, let's jump to another live class. This time we are going to go to Mrs. Gully's group. Looks like some grade 6s hanging out with us in Virginia. Let me turn their microphone on. How we doing, grade 6s?
Good.
There they are. All right, who's got a question?
Why do like animals attract plastic stuff?
That's a great question. So the thing is that It's funny with humans, we all know what plastic looks like, we know where it's coming from, and we know that we shouldn't eat it. But in some cases, animals, they don't really know all this about plastic. For example, if you're a fish and you're really good at swimming and you're darting through the ocean and you're swimming around and you see smaller fish and there's a piece of plastic in the middle, that fish might be such a good predator that he might get a small fish and then target a piece of plastic without really knowing it. Other times, there's other types of animals like jellyfish. Have you seen jellyfish before? Yeah, the big blobs, right? In one case, there was a whole bunch, scientists found plastics inside a jellyfish. And the plastics that they found were these really clear films, almost like those food wrappers, but see-through plastic. And the scientists thought that the jellyfish thought that was food. So it just ate it because it couldn't see the difference. In some cases, birds smell out their food. They use different types of olfaction. So they basically smell out food in the ocean. And plastic, in some cases, can carry smells with them that smell like food, but they aren't food. So depending on the animal, they just might get tricked into thinking that this is part of what they should be eating. And really, it's hard to explain to wild animal that this is bad for them. But the problem is there's just so much plastic in the ocean that it's tricky. It's tricky to be an animal right now.
All right, excellent question. Mrs. Edwards group, some fourth graders hanging out with us. Let me see if I can get their microphone turned on. There it is. Hey, Mrs. Edwards class. Hi. Listen, I need you to help me out before your question. On your sign up, it just says you're in the US. What state are you guys in?
We're in Colorado, Gunnison, Colorado.
Perfect. All right, we're ready for you.
Hi, my name is Damien, and I was wondering how plastics affect freshwater ecosystems as well as saltwater ecosystems.
That is a great question, Damien. Thank you so much for asking that. That's the thing is like in science recently, all the scientists have been worrying about plastics in the ocean, but the problem is that a lot of the plastics that enter the ocean come from freshwater sources. So things like rivers, creeks, lakes, a lot of the plastic actually ends up there first. It breaks down a bit and then it enters the ocean. Animals in freshwater are very similar to the ocean animals that I just described. In a lot of fish species, for example, fish will eat plastics. So we're finding in lakes, for example, that there's more different types of fish that are eating plastics just because plastics are really good at sticking around in freshwater environments. They don't really have the chance to move around and escape to the ocean as quickly. And as a result, the animals that live in these environments are a little more susceptible to going out and munching and eating those plastics. So that's how they're affecting them there. Now, the problem with plastics is this is a really, really big question that we're all trying to work on is how much harm do they cause animals? In some cases, plastics like the ropes I showed you in the presentation, they can tangle different types of birds and you can see that animals get caught in plastics. But when animals eat plastic, we're just beginning to understand how much harm it can cause them once it's inside their stomachs. And what we know in the ocean is that they're starting to hurt animals, but we need a lot more scientists working on the freshwater questions. So thanks for that, Damien.
All right. We're going to take a little trip to Innisfil in Ontario.
Nice.
We've got Mrs. Benfield's group joining us. Let's see. Oops. There we go. Let's see if we can get that microphone on. How are we doing, boys and girls?
We're actually in Alberta.
Oh, Alberta. Nice.
Oh, okay, perfect.
Can you go ahead? Where does all the plastic go when you pick it up?
Where's all the plastic coming from? Did I hear that right?
Where does all the plastic go when you pick it up?
Sorry, I couldn't quite hear that. Yeah,
he's wondering after you pick it up, then what do you do with it, with the
Right
plastic
on.
you pick up?
That's a great question. So right now what we do is we bring it to a waste management facilities, which is basically a fancy word for we put it in the right spot garbage should be, in the big dump that's close to our house. So basically what happens with that garbage is we put it in garbage bags, we make sure that everything's secure. And then it goes into basically a landfill where humans, which isn't my system that I created, but what we do, or this facility does, is they dig a hole and they put the garbage in the ground. And this is one question that always bothers me when I do these cleanups, because you want to make sure that this garbage doesn't hurt any animals and doesn't hurt the environment in the future. And unfortunately, with the way our system for dealing with our garbage is set up, is we just move it from one area to another. And I'm not really happy with that. So I'm hoping that I can learn enough to help change that in the future, because we shouldn't be creating as much garbage as we do, because we don't want to be putting it on the land. That's the last thing we want to do. We don't want it to go in the water either. So we need a lot more folks like you who are worried about, these questions about garbage and waste to really help make the system better. And one way that some people are doing that in other countries like Norway, up in the north, they have a very, very, very efficient recycling system, where what they do is when you buy a bottle of Coke, for example, or a bottle of water, you pay a lot for that bottle, and then they pay back, the companies pay back to take it. So, and then their recycling system, so they basically take all these bottles and they recycle them, and it's really efficient. And that's basically the model that we should be kind of following, is that everybody is responsible for the garbage, and companies are too.
All right, that would be a nice model. Hopefully we start seeing that implemented a little bit more. So we're going to go to Mrs. Gary's class. They are in Idaho. Looks like some 3rd and 4th graders. Let's see if I can get that. There they are. How are we doing, Idaho?
Good.
Oh, and we have your camera too. Very cool.
I have a question.
Sure.
Do you ever have to use scuba gear for your research? If so, how do you stay warm?
That is a great question. I love it so much. It is really, 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 really cold where I live. Sometimes the water gets below 0 degrees, so it's like freezing basically. I don't actually scuba dive in Newfoundland. I have scuba dived on the west coast of Canada, where it is a bit warmer. But I actually have a lot of friends who do scuba dive in Newfoundland. And what they have to do is they put on a lot of clothes to make sure they stay warm. So they put on these, so basically like a version of pajamas, but they stick really close to your skin. So like it's a really tight kind of thermal wear. They'll usually put a couple layers of that. They'll have a sweater on. And then there's something called a dry suit that basically keeps the water out. So you're dry the whole time. And what this does is it helps you stay warm when you're really, really cold in the dark in these really hard waters. So, but there are people who do scuba dive and they do pick up garbage from the ocean. So there's a whole nother another sector of folks there.
All right. Such a good question from Idaho. Let's go to another class that happens to be in Idaho, Mrs. Wolf's group. Some grade 5, 6s hanging out with us. Let's get that microphone turned on. How are we doing, boys and girls? All right.
Read the question.
Okay. Hi, my name is Cordy. And our question is, what was the most surprising thing that came out of your studies?
Oh, that's a great question right there. Okay, so this is gonna sound really weird, but you know the pictures I showed you before? The poop samples, the ones where I held the birds and got them to poop on a notebook? I found out when I collected over 100 of these poop samples that they were all different colors. And if you line them up in a row, they look like a rainbow. So that was my most surprising moment, was wow, like birds can make really beautiful poop. So that's what I found out with my science that was the most surprising. And what's even cooler, because I'm a nerd and I love learning and researching, but with these rainbow poops, you can actually start to look at the patterns of what the birds eat and how it affects the color. So one cool thing that I'm working on with these samples now is understanding what food did that bird have to eat to make a certain type of color of poop. And what this does is this can basically be used as a model in how we understand what kind of animals eat what kind of food and what kind of poop it creates, so that you don't actually have to hurt the animal to see what's inside its stomach. You can just collect the poop samples and it'll tell you a whole bunch of information. So that's the most exciting thing I've ever learned.
All right. Sounds a little messy, but it also sounds like a good thing in the end if you can narrow down a way to do that without having to check out the animal stomachs.
Oh, for sure. Yeah.
All right, Mr. Hall's class, Canton, Michigan, 5th graders. Let's get that microphone turned on. There it is. How we doing, Michigan?
What animal do you think is most affected by this pollution?
By plastic?
By this pollution, yes.
Oh, okay, yeah. So, that's such a good question. There's a lot of animals out there that, are affected by plastic. So I don't want to pick any favorites, but a lot of animals that are really tiny, like have you guys ever seen clams or mussels? The shellfish? Yeah.
Yes.
So, yeah, so those guys, basically when they eat their food, they eat whatever's in the water. So they just suck in a whole bunch of water, and basically because they can't pick the water they're feeding from, anything that's in there gets, eaten by them and it gets in their bodies. So plastics are actually, quite abundant in these animals that don't really go out and they don't go after their prey. They just suck everything in. So I would have to say it's the smaller guys. It's the mussels, the clams, some species of birds too. They just like the smell of plastic and they like the look of it, and they'll eat a lot of it. So like albatrosses are another big bird species that eat a lot of plastics that you can see pictures of. They live pretty far in the ocean, so I mean, it's easy for them to get at it. So there's a lot of animals out there, but there's a few of them that are especially hard hit.
All right, Justine, I think we can probably squeeze in 1 or 2 more questions, but I know that classrooms are going to have lots of questions. So if you're cool with it, can you share your Twitter handle and maybe the classrooms can tweet some more questions at you afterwards?
Of course, right on. Do you want me to say that or write it out to you, or?
No, go ahead, and I can send it to the classrooms
Okay,
after too.
cool. So it's at JAMMENDO, so Jamendo 1.
All right, perfect. So I think I may have put in an earlier email, so classrooms feel free to tweet a few more questions, but let's see if we can visit 1 or 2 more classrooms. Let's try Mrs. Edwards' class. Do you guys have a follow-up question?
What have you already solved about oceans plastics?
That's a great question. So what I've been really lucky to do is working in Newfoundland, so working where I live, the province, didn't have too much plastics research going on maybe 10 years ago. But what I've been able to be a part of, and it's not just me, it's working with all these amazing people that I'm lucky to call my work colleagues that I'm with and the different research labs at the university, is I've been able to help understand which animals are eating plastic. Because the thing is that there's so many animals in the ocean and we just don't know enough about where plastics are ending up. I've been able to help paint this picture of where plastics are ending up in our ecosystems and on our beaches. But in terms of solving things, this is the first step, is gaining all this information. And then the next step would be going to people like companies who actually are the ones who are creating a lot of plastic and, showing them the information that I've helped put together and asking them to try to make an effort to make less plastic, or doing that with governments too. So that's that's something I hope to be a part of.
All right, Mr. Bruno's class, do you guys have a follow-up?
How many animals have you touched?
That's amazing. Oh my God, there's to grab them for scientific purposes and instead of petting my cat kind of deal. I've seen a lot of animals, probably over 200 types, over easy. I worked a lot. I worked in so many different fields where I got to see animals. So there was a time when I worked with insects. I worked at a museum that had thousands and thousands of insects. And, one thing that people don't realize, especially in marine biology, is that there are so many different types of insects and bugs in the world. So, even though they might have slightly different colors, they're totally different species. So yeah, I would say well over 200.
All right, let's squeeze in 1 more. Let's go to Mrs. Gully's group. Let me turn your microphone on. Do you guys have a follow-up?
Yes, we do.
Are oil spills the biggest problem as plastic?
what was that question? I didn't quite hear. It must be the connection.
Are oil spills as big a problem as plastic?
Oh, that's okay. She's wondering specifically about oil spills. Are they as big an issue as plastics? Whoops, I think I muted Justine by mistake.
The oil spills are a very big issue right now. Oh, yeah, I'm good. You can hear me, right? Yeah.
Yep.
So oil spills are a really big issue that happens. So basically, when we go out into the ocean and we drill for oil, or big ships transport a lot of oil, they'll spill a lot of the times. And the problem is that animals have a lot more access to that oil than, sometimes in cases of plastic, where plastic is, how I said it lives all over the ocean, it's in the water, it's in the bottom. Sometimes with oil spills, it just ends up in these big blobs, and animals that are in that area are really, really badly affected by it. Now, what's really cool to mention too is that plastic is actually made from oil. But it's just made from oil way later in the chain. Like, it's almost like taking oil into a kitchen and making it into plastic, right? You have to follow a full recipe to make it happen. But basically, with oil spills, they cause a lot of damage to the environment. And I think both of them are really important to look at. It's just basically different stages, right? You're taking those raw ingredients, and that's affecting animals in one way, and the plastics are the cooked kind of cake from oil, and it affects them a little later. Yeah, that's a great question.
All right, excellent. Well, I want to give a quick shout out to Explorer magazine. So it's a really cool magazine that National Geographic puts out to classrooms. I know there's some classrooms tuning in today who get Explorer Classroom delivered to their classroom. And Justine, I believe that you were just recently featured in Explorer magazine.
I was, yeah. So if any of you folks have the magazine, that was me holding all the birds. So I'm so glad to have joined you today. Yeah.
Oh, I see one classroom, Mr. Bruno's classroom there. Let me see if I can pin them to the screen. I think they're all holding up there we go. They're holding up their Explorer magazine.
Oh, that's
awesome.
So cool. Thank you, guys.
Very cool. Good job, Mr. Bruno's class. Yeah, so definitely worth checking out for classrooms. And too bad you couldn't just reach out and autograph some of those for them.
Oh my gosh. Let me know if you want autographed copies. Reach out to me on social media. I would definitely be happy to mail a couple. So.
All right. Awesome. Well, first of all, I want to give a huge shout out to our classrooms for joining us live today. Thank you for all the awesome questions and spending your afternoon with us. Justine, huge thank you to you and to the museum as well for letting you kind of close off that little section and hang out with us today.
Yeah, so massive thank you to the Geo Center. I mean, it's a great facilities, and it's so cool to be calling all of you guys. So thank you so much for making time.
All right. Well, boys and girls, thank you so much for hanging out with Explorer Classroom today. Check out nationalgeographic.org. Under education, you can find our upcoming events. We still have some more plastic events coming up. So we look forward to seeing your classrooms in action. And Justine, I think the last thing we need to do today is unmute all those microphones, see how loud the classrooms can be, and get a good bye and thank you. So here we go. Microphones are coming on. No denying that they are always ready for that and do an awesome job. So once again, Justine, thank you so much. And we are going to sign off for today.